listening to The Quiet Archive. This record is filed under the Operational Records Division, Mechanical Wing. Today we're looking at conveyor motor systems and doing a belt tension audit. This entry documents a routine inspection cycle conducted within the conveyor motor chamber, where belt-driven transfer systems operate continuously as part of the facility's material transport infrastructure. No anomalies are expected, and the system operates under stable mechanical load and maintains a consistent rotation cycle across its pulley assembly. The purpose for this audit is to observe belt tension, monitor the pulley alignment, and confirm that rotational movement maintains a standard operational tolerance. The inspection begins from the maintenance platform positioned adjacent to the conveyor motor housing, and the platform provides a clear view of the belt path as it travels between the drive pulley and the return pulley along the conveyor frame. Lighting remains dim, but it's sufficient for observation. Ambient machine noise is low, but consistent, and the inspection record will proceed slowly. You may listen, or you may drift. The archive will continue either way. Observation begins now. The conveyor motor chamber remains quiet at this hour. Industrial lighting casts a steady glow across the steel framework supporting the conveyor assembly. The motor housing sits mounted to a reinforced base plate which is positioned beside the conveyor structure. A wide rubber transport belt runs the full length of the system, looping around the drive pulley near the motor and continuing along the conveyor rollers before returning along the lower track. The belt surface moves slowly, maintaining a stable transfer speed calibrated earlier in the shift. Above the belt, the metal frame of the conveyor stretches across the chamber like a narrow bridge, carrying materials from one station to the next. Inspection walkways surround the machinery. Guardrails run along the maintenance platform to provide safe access to the motor housing and also pulley assembly. The belt itself travels in a continuous loop. From the drive pulley, it moves outward across the conveyor bed. It passes over evenly spaced rollers that support the surface. Then it reaches the far end of the conveyor frame, where the return pulley redirects the belt beneath the structure. From there, the belt travels back toward the motor along the underside of the conveyor frame. Eventually, it reaches the drive pulley again, and the cycle repeats. Above the motor housing, a small inspection light illuminates the tension arm assembly. This adjustable component maintains the proper tension across the belt loop. The tension arm extends slightly downward from its mounting bracket. A steel roller presses against the return gently. Its purpose is simple: Maintain constant pressure. Prevent slack. Preserve stable motion. Air moves slowly through the chamber ventilation system. The airflow is subtle, barely noticeable. The belt continues its motion without any interruption. The chamber remains calm, and observation can continue. The conveyor motor rotates steadily. Inside the housing, the electric motor drives a steel shaft connected directly to the drive pulley. The pulley turns at a constant speed. As it rotates, the rubber belt moves with it. The belt surface advances slowly along the conveyor rollers. Each roller supports the belt evenly as it passes. No vibration is visible along the frame, and the movement remains smooth. Another rotation cycle completes. The pulley turns, the belt advances, the rollers carry the load. Another cycle completes. The belt maintains its alignment along the center of the conveyor frame. Its edges travel parallel to the steel guides mounted along the belt path. There is no lateral drift. There's no visible oscillation. The belt glides across the rollers with quiet consistency. Another cycle completes. The motor continues turning. The pulley continues rotating. The belt continues moving. Inspection instruments mounted near the motor housing display stable readings. Temperature indicators remain within the normal operating range. Motor casing warmth remains moderate. The vibration monitor mounted beside the drive assembly reports minimal movement. Numbers on that display remain steady. The machine does what machines often do. It repeats the same motion again and again. Another cycle completes. The pulley turns once more. The belt advances along the rollers. The conveyor structure remains stable, and air continues drifting slowly through the chamber. Observation can continue. The belt moves, the pulley turns, another cycle completes. Then another. The tension arm rests lightly against the underside of the belt. Its roller rotates freely as the belt passes beneath it. Pressure remains constant. The belt does not sag. Another cycle completes. The motor maintains its steady rhythm. Rotation remains even. The conveyor rollers spin quietly beneath the moving belt. Each roller turns for a moment as the belt passes over it. Then it slows again once the belt moves forward. Another cycle completes. The belt surface continues its path across the conveyor frame, from motor pulley to far end return pulley, then back beneath the structure, then forward again, and the loop repeats. Another cycle completes successfully. The chamber ventilation system hums quietly above. Air passes slowly through the intake ducts. Warm air drifts upward along the tall walls of the chamber. The movement is gentle, barely noticeable. Another rotation completes. The belt advances. The pulley turns. The tension arm maintains pressure. Nothing changes. And that is the purpose of this inspection. Machines working normally often look exactly like this. Quiet motion, stable rhythm, continuous repetition as another cycle completes. The belt advances again. Another. Observation continues. The belt tension gauge is checked. The measurement falls within the acceptable range recorded in the maintenance log. Tension remains consistent along the length of the belt loop. The tension arm position confirms the reading. Its calibrated indicator shows that belt pressure remains within standard tolerance. Drive pulley alignment is also observed. The pulley rotates on a straight axis with no visible lateral movement. Shaft alignment remains stable. The bearing housing shows no irregular vibration. Motor temperature, the readings remain steady. The digital sensor mounted near the casing reports a stable thermal range. Cooling airflow around the motor housing remains unobstructed. The ventilation intake above the platform continues drawing warm air away from the machine. The return pulley at the far end of the conveyor frame remains aligned with the drive pulley. So the belt approaches the pulley evenly. It wraps around the curved surface smoothly. Then it travels back along the underside of the conveyor frame. And another cycle successfully completes. Inspection markers along the belt edge confirm that the tracking remains centered. There is no evidence of drift, no sign of uneven wear. The conveyor rollers remain evenly in the frame. Each roller turns briefly as the belt passes across it, then rests again. The mechanical rhythm continues as another cycle completes. System readings remain stable and the verification continues. The conveyor system continues operating quietly. The belt travels along its path once more. The pulley rotates, the rollers turn, another cycle completes. Then another, and another. The chamber remains calm. Air moves slowly through the ventilation ducts above. The motor continues its steady rotation. The belt remains under proper tension. Its surface glides along the conveyor rollers without resistance. Another cycle completes. The inspection platform remains still. The railings cast soft shadows across the metal floor. The motor hum continues. The belt advances and another cycle completes. Nothing changes. Nothing needs to. The system remains stable. The conveyor motor continues its quiet work. The belt tension remains correct, and the pulley turns and turns and turns again. The belt advances once more as the observation continues. The arc is open. The system remains in motion. Another cycle completes, then another. The record continues quietly.